Right on to the next one. Leak code number 49, group anagrams. We're doing this problem to get more practice with the hash table. And not only that, we'll be using the hash table in a unique way. Let's define the problem. Given an array of strings, return the strings grouped by anagram. The definition of an anagram is when two words have the same letters, but they can be in a different order. So let's look at a few string examples. Of these four, A, B, and BA have the same letters, so we would group them together as anagrams. The other two are not anagrams, so we would return them in their own distinct groups. So to formally define our inputs and outputs, the input is an array of strings, the output is an array of strings, with each subarray holding anagrams. One edge case could be getting past an empty array as an input. And one thing we have to be careful about assumption-wise is that we're checking for complete anagrams, so partial matches don't count. Let's start to think of a solution. Your mind's in the right place if you're thinking about the hash table from the last question, because we are considering different characters and how often they appear. So let's say we use the character counter technique, and we can see that these two hash tables are identical. Unfortunately, when we think about comparing multiple hash tables, we can't just use the equal syntax. It won't work. We'd have to compare every key in every hash table to every other one. Very inefficient. Not to mention the extra space needed for all these hash tables. But there is a better way. If we want to use a single hash table, what could we use for the key? Maybe there's a way to make two anagrams the same. In fact, we can sort anagrams by characters, so all the A's come first, all the B's come second, and effectively make any two anagrams the same. So running AB and BA through a sort function will make them the same. So we're still using the hash table. This time, however, the value will actually be that array of groupings. So instead of the counter from last time, we're actually going to put the array itself as the value of the sorted key. When we sort the keys, looping through a sample input would look something like this. First, AB gets sorted. This doesn't change it, so we check the hash table. There's nothing at that key yet, so we push in a single cell array with AB in it. Next loop iteration, we'll look at BA. We sort this and it also becomes AB. Now when we look into our hash table, the key already exists. So we will simply push or append into the array at that key. Next for BB, we sort, see it doesn't exist, and add it. Same case for BBA, sort, it doesn't exist, so we add it. At this point, we've built up our hash table, but the last important step is to convert this to an array of arrays. So we already have arrays at each key, and we need to just get the values in a flat array. Now there's a pretty simple way to do this in both JavaScript and Python, which we'll look at as we code it up. But first, the pseudocode. Okay, we know what we want to do, so let's convert our ideas into this format. We're going to have to loop through all the strings. We already know that. And then within the loop, at each string, we're going to have to sort the string characters to create our keys. Once we do that, we're going to have to do a similar check as the last problem. Does the key already exist? If so, we'll add to the array at that key. If it does not exist, then we'll have to create that array with the value we are on with the loop. So this part is also very similar to the last problem. We've got our JavaScript starter code ready to go with our single argument strings for our array of strings. The first thing we're going to do, like last time, is initialize our hash table to an empty object. We'll then loop through our strings with a for of loop, giving us access to each string in the array in the variable str. Now, how do we sort a string? Well, this is the part you might not have gotten unless you're familiar with this pattern. What we want to do is split the string into an array of characters. To do this, we'll call the split method on each string, splitting by the empty string, meaning every character in the string will become an item in the array. So if we have a string like this, ABC, it will become A, B, C. The reason we have to do this is because we cannot call the sort method directly on a string. It has to be on an array. So we'll split and then we'll sort. And finally, we will join the string back together. And what I'm doing here is called method chaining. So the result of this split, we can call another method on. So the result of split will be sorted, and then the result of the sorted output will be passed to join. Remember, method chaining, common in JavaScript and also other languages. So we'll join by the same empty string characters so we get back to our original string, reversing the original operation. So it'll be kind of like this. And that'll give us what we want, and we can store that in a variable called sorted. Once you can master method chaining, if you haven't already, it's good for not only solving algorithms, but JavaScript in general. So we're just getting a little practice with that here. Just to recap one more time. Split converts into an array, we sort that array, and then join converts our array back to a string. Okay, now we can check our hash table for the presence of a value at our sorted key. If it does exist, we want to use the array push method, and we can do this because we know if it exists, there's an array in that value. So if it does exist, we'll push in our current string value. Be careful not to push in the sorted value. Otherwise, we can go to that key index and set it to a single cell array, initializing it. And make sure you're making this an array so we can push into that later. Finally, and this is another slightly tricky part, especially if you're not familiar with this function, is the object.values function. And this is the way we convert our hash table into our output format array of arrays. This object values function takes an object as an argument, and all it does is pull off all the values and throw away the keys. So we know we have an object with arrays as values, and what this will do is create an array with the values as entries, which is exactly what we want. At this point, we can just return the result of object values, and this should be good to go. All right, let's talk about time complexity. We do have one loop, so we know this will be n, proportional to the size of the input, because we're going to be looping over every item in the input. Another thing we have to keep an eye out for when we're looking at time complexity is sorting operations, because they are very expensive. When we use the built-in sort method, the time complexity is n times log n. There are more and less efficient sorts, but the built-in one is n log n, and we're going to get into why later when we get into the sorting section of the course. Now, sorting is n log n, but it's inside the loop. So again, we're going to have to multiply this n log n by the outer loop n. Ultimately, our time complexity won't be that clean. N times m log m, with n being the number of input strings or the length of the strs array, and m is the longest length of one of these strings, because that is the worst case of what we're going to be sorting. So not exactly clean, but that's what it comes down to. If we think about space complexity, worst case, our anagrams are all going to be unique. So we will need n unique keys, where n is the size of our input, to store in that hash table. In other words, we will need linear space, or O of n space. That's group anagrams done. Hopefully you're starting to see why the hash table is so useful in so many different situations. Even if not, we're going to continue to use it, so be prepared for that. Also, fun fact, this was my coworker's go-to phone interview question. He literally asked it every single time. Anyway, I'll see you in the next video.